All right, so conceptually, the idea of mapping, it might seem as it's straightforward. I mean, basically, you start off with some 2D image, right? And basically, you want to be able to say, well, I have a some kind of destination 3D surface. How hard could it be of just iterating over, the two by two image on the source image, right? And then mapping it into some 3D space of each pixel on some kind of surface. But it turns out that it's not as trivial as it might seem. There's several various types of coordinate systems that are involved. Certainly, the source image has its own coordinate system, right? It's x, y representation of going up and down, left and right of the image. The 3D surface might be the results of some complex 3D mesh, or maybe just a simple surface of just a couple of triangles, or it might be thousands of triangles, right? And so the options are somewhat limitless, right? On how is it that we're going to decide that this pixel, maps to this corner over here. This might be thousands of triangles of inside of a mesh that has been stretched out. It might have been translated, rotated, scaled. Deciding on how is it that we map this to this is not. It could be fairly thorny, right? So there's quite a bit of many different types of coordinate systems that are involved, right? The surface area that we might be mapping to might be based on some kind of parametric coordinate system that describes a cylinder or sphere based on some equation that given the radius of a sphere or the height and radius of a cylinder, we have some sine, cosine multiplied by some angle that is iterating over some from 0 to 360 and whatnot, describes the geometry, right? And so we need to be able to say, okay, well, those are the functions that describe our 3D model. What is the relationship between those equations that describe our sphere, our cylinder? How does that map to the texture coordinates? So the texture coordinates has its own coordinate system from the image that is being mapped, right? So where you have going horizontal or vertical, x, y going left to right, or y going from top to bottom. And so as you iterate over the 2D x and y position sometimes we use the s and t as opposed to x, y. From the source image, how does that map to the radius and angle as you iterate and generate the surface area of a cylinder or sphere? Then that sphere or circle or mesh has been moved around, has been translated, has been rotated, has been scaled. So all those transformation matrices, they also play a role into the fact that those pixels from the source image also needs to go through that same transformation. Those pixels that you say, well, are mapping to this corner in the 3D space, right? How those also need to go through the transformation and putting it so that it maps to the correct point on the destination surface. And then you have all the transformation from doing all the perspective or orthogonal transformations that eventually convert that back into 2D so that it can be rendered on a Windows screen. So definitely, there's tons and tons of these, a lot of math that goes into this, doing all these transformations, right? You have the parametric coordinate system that defines what is the geometry of the 3D objects. Again, whether you're changing some variable for the angle for a sphere or cylinder, and then the height of a cylinder or whatnot that defines the entire object that you're trying to render, or it could be some mesh, like our hat, Mexican hat surface, right? That is based on some complex equation as you again, based on sines, cosines, and tangents, and some distance from a origin. As you move away from the origin, right, this attenuates this hat and generates our surface. So that certainly has its own equation and parameters. Most of them have one or two or even three parameters that define our surface. And how does that map with the as you're moving along the t and the s coordinates of your source texture? How does that then translate over the rotations and translations and scaling of those mesh or parametric geometries onto a world coordinates, and eventually how does that map on how that render back into our camera, into our window. So certainly there's lots and lots of transformations and coordinate systems that are involved and make this non-trivial.